This next technique, to me, it looks, but it's not. That's not what it is. But it almost looks like somebody combined star plots and parallel coordinate plots. Uh, Not quite what they did, but they tried to get kind of disambiguate the hairball. And so instead of the hairball kind of going in the same plane, they kind of use 3D to move them around. And I have a video to show for it. And I will get back to this slide in a second. And I will combine them because I need to go back to the video and I want to keep going back and forth. And after this technique, the combination of, it's kind of parallel coordinate plots in 3D. Then we're moving to dust and magnet, and I have a video to play for it. To me, this is one of the cutest techniques. It's like, how did they come up with this idea? Why didn't I? It's very simple. My understanding is that part of it was actually developed for a class at Georgia Tech that looks like this one, information visualization. Class like this one. They probably spent some time outside of the class to polish it and publish it. Uh, but the idea was part of the project for this class. So they came up with dust and magnets. Okay, so that being said, first we'll look at the 3D visualization, and they kind of have some ways to try and deal with them. And then we'll look at dust and magnets. Okay, so I don't think this has sound, but I may be wrong. I may have to kind of talk. So they kind of go through this idea. We have parallel coordinate plots, and they want to unfold it in 3D space. You kind of see what they mean. So here is all the, it looks like a hairball right now, lots. So what if we kind of move it around in 3D, and then each line gets its own little 3D space? So instead of all being in the same plane, you kind of take them and unfold them on the z-axis, on a circular axis. And then they use transparency to allow you to kind of see what happens with those. You see some of these planes are higher, but on some axes they hit them lower. Another way to compare them, and again, these are problems with 3D representation, but they try to give us tools to compare them. Another way was that interactive ring. Here is using color to allow for comparison. And then here they're using color, but they kind of make it, instead of being continuous color, they put it in, it changes with concentric rings. So the color in this ring is kind of the same in one ring, and then it changes as you go on. So same thing, this is just the 2D representation. They can apply color to them, but then at some point they will start and move them around. It still looks like, even with color, they look like a hairball. So here is, they select they select part of it and they take it away in 3D. So now you separated your visualization. Previously, they took each and every line and separated in 3D, but now they took one set and moved it to the other. So you have kind of your set, and you can keep doing that as many times as you want. You can have these planes kind of being all over the place. So you can pull individual points and kind of see their shape. So that part was here. Kind of, I have a small recap on this slide. They use perspective in order for us to see everything. So you remember that each of these threads on this line, they kind of go into the screen now. It's as if I'm taking this and moving it, turning it 90 degrees, taking the screen and moving it 90 degrees from the top. They use these circles to allow comparison in 3D. So these are some interactive circles, or they can use color rings. So now move into dust and magnet, and this one has sound. Okay, let me magnify. So I'm going to start it in 3, 2, 1.
In our everyday lives, we encounter many types of complex data sets in decision making. For instance, when we are choosing a college, buying a house, purchasing a car, or even choosing a cereal for our family's breakfast. These data sets are complex not only because there are many candidates to choose from, but also because each candidate has so many variables to consider and compare. To help analysis and decision making, we have developed an information visualization system called Dustin Magnet that uses a magnet metaphor to help people more easily interpret multivariate datasets. In Dustin Magnet, the small circles, called dust, represent the data cases, and the squares, called magnets, represent the variables. As a magnet is dragged around on the screen, the dust particles move toward it at different speeds. The data items with higher values for that variable or magnet move faster. In other words, they have a higher attraction with the magnet, which is the basis of our metaphor. If there are multiple magnets, dust particles are attracted to all of them simultaneously, and their movement is a cumulative effect. Dustin Magnet, which was created using Java and Piccolo, contains 3 different windows. The main one on the left side is where the Dustin Magnet interaction takes place. On the top right is the control window where various features of Dustin Magnet can be manipulated, like the color or size encoding, filtering, or changing the magnitudes of magnet's attraction. Finally, on the bottom right is the detail window where the details of selected data cases are shown. In the following scenario, a data set of different cereals with a number of different variables is loaded. Suppose that we are seeking a cereal that is low in sugar and fat, but high in protein and vitamins. We can bring magnets for each of these variables into the view to help explore the data set. Some of the data items are still on top of each other in the center of the screen, so we use the Shake Dust command to reduce occlusion. Shake Dust merely moves the dust particles that are touching a tiny bit. At this point, a number of the best candidates are near the top of the screen, so let's find out their manufacturer. We can encode the manufacturer by the color of each dust particle. And we quickly notice that many of the best choices are Kellogg cereals, here indicated in green. Since the number of calories is important as well, we can encode the number of calories per serving in each cereal by the size of the dust. We specify a minimum and maximum size, and the display updates appropriately. Only one of the green ones appears to be low in calories. Selecting it identifies the cereal, all bran with extra fiber. We've tried that before. We want something a little tastier, so let's look for other options. Perhaps we can relax the importance of vitamins in the cereal since we can supplement breakfast with a multivitamin. We can modify the magnitude or pull of the vitamins variable by lowering its magnitude through the user interface. Now when the magnet is moved, it has less of an effect on the dust particles' movements and positions. Suppose that we are also concerned about sodium, so we can filter out cereals with high sodium content. Notice how a number have vanished from the screen. After making these adjustments, a few good potential candidates were made. Special K looks like a particularly appropriate choice. In usability tests with the system, we observed a number of different usage patterns. Some users even used Dustin Magnet in ways we hadn't imagined. For example, one participant only used the filtering features. Another stacked several magnets on top of each other and used the attract dust and repellent features to group the dust. And yet another relied on the detailed view in order to make final decisions. course, dust and magnet is not limited to serial datasets. Other multivariate datasets can also be used. For example, the data of new passenger vehicles for 2005 or a list of mutual funds can be imported to Dust and Magnet and explored by users instantly. We hope these scenarios illustrate some of the potential Dust and Magnet has for the everyday user.
I brought this here because if you look at this picture, we can handle quite a lot of, I think there's hundreds of data points in here. So probably we can do something like that. Thousands, maybe too many. We kind of run out of, there'll be too many on top of each other. But if you look at the dimensions, in other words, the magnets, there's about 8 right now or 9. So the more you have, the less you're going to be able to distinguish between them. So I think, again, they're limited probably to 20. And then you have to use some other, plus they have some other tools, not only the dust and magnet, but they have the size and the color and the filtering. But if you ignore that, there aren't that many dimensions that you can place on a magnet by itself. The order of the magnets obviously matters. If you want some, if you, like in their example, if you want something with low fiber and high calories, or the opposite, you kind of have to put them in different places on the screen. It's not only the order, but it's where you place them on the screen that will make some difference. And that's kind of pretty much my analysis on dust and magnets. And I think I will stop here. The next topic takes a long time to explain.